Okay, so what is the difference between an angle of elevation and an angle of depression? Daisy? Elevation is like somebody looking up, right? And depression is? Good, somebody or something looking down. So where are our angles of depression in that figure? 3 and 2, because the 3 is the bird looking down and 2 is the man looking down. 1 and 4 are angles of elevation because the man is looking up and the bird is looking up. The only thing then with number 5, typically when you do these, you're going to end up using tangent because you're usually looking for the height. So for example, in this one, we're looking for the height of the balloon, so that would be our x. So what proportion would we use here? Tan 67 equals x over 14.5, or some people converted it to inches, and I think that was 174. Is that right? 174. Either way, you end up with 31.16 feet, or approximately 409 inches. Okay, so the only thing with angles of elevation and depression that gets a little bit tricky is if you have something like people are in a hot air balloon, all right, and what could be on the ground? There is a dog on the ground. All right, there's a dog on the ground. That looks more like a pig with a crown, but there's a pig with a crown standing on the ground. And if you want to figure out how far away you are, let's say the angle of depression from the from the hot air balloon is 23 degrees. So if it's the angle of depression is 23 degrees, where is that angle? Okay, so it's like from a horizontal line, it would be right here. So if you're using angle of depression, what do you have to do? Subtract from 90 so that you can figure out this angle, because you'd need the measure within the triangle. So the trickiest part with angle of elevation and depression is when it's depression, you have to subtract from 90 to get this angle. So this would be 67 degrees, and then let's say the hot air balloon were 200 feet in the air. All right, what? The 200? Yes, the 67, no. All right, so to get 67, we subtracted from 90, and then let's say we're 200 feet in the air. So then what measure would we use here? Again, typically it's going to be tangent. Tangent 67 over x over 200, right? It's opposite over adjacent. Good. Okay, so that's the trickiest part with elevation and depression. Just remembering for depression, you always have to subtract from 90. All right, so we have a lot to cover today because of the fire drill last week. We're going to do 2 lessons. You guys are going to have a review on Thursday, and your test will be on Friday. I know Friday's a short day, but we have a block, so you guys will still have like 56 minutes. What? Yeah. So I think I see you at the end of the day, right? It's a Monday, Friday? Yeah. Yeah. Okay, so I'll see you guys for 7th and 8th before we go to Mass, but you guys will have that whole time to work on the test, okay? So what we're going to do today is law of sines and cosines. Then we're going to talk about vectors. Then you guys will do a review on Thursday, and we'll take your test on Friday, okay? So that means homework is due on Friday for Chapter 8. All right, so homework is due on Friday for Chapter 8. Okay, so law of sines and cosines is a way to figure out missing legs in triangles that aren't necessarily right triangles, and we're going to use ratios to figure that out. So take a look at this picture up here. The altitude of a triangle, that's h in this figure. What's an altitude? What's an altitude? It's kind of like the height of the triangle. It goes straight from one vertex down here, and it has to make a what? It makes a right angle. It's perpendicular to the opposite side. So an altitude goes from the vertex, and it's perpendicular to the opposite side. Okay, take a look at this. If I have sine A, what is sine? So it's opposite over hypotenuse. So the sine of A would be equal to what? H over, not C. Why is it B? Because if I'm looking at this, it looks like C is the hypotenuse of the triangle. How come sine of A is H over B then? What triangle are we really talking about here? We're talking about the smaller triangle, right? So sine A is H over B. What about sine B? Would be H over A. Because now we're talking about which triangle? That middle, that like middle-sized triangle. Okay, what about sine C? Could you do sine C? Why not? The opposite is the hypotenuse. So sine C, sine of 90, is actually just 1. If you do that in your calculator, sine 90 gives you 1 because opposite is the hypotenuse. So opposite over hypotenuse would be like C over C, which always reduces to 1, right? Is sine 91? Good. Okay, so you don't need to worry about that one. Now, take a look at these. Do they have anything in common? They both have an h in common. So let's solve this for h and see what happens. How would I solve this for h? What would I do to get rid of the b here? Times b. So if I multiply by b here, what do I do over here? What happens here? That's gone, and what do you have left? H equals b times sine a. Okay, what if I solved for h here? Times a, and that gives me what? A sine b equals h. If they're equal to the same thing, what can you say?
B sine A equals A.
How? So Bianca said b times sine a equals a times sine b. Transitive property or substitution or however you want to look at it, right? If this is equal to h and this is equal to h, then these two things must be congruent, the same as each other, right? If a equals b and c equals b, then a and c have to be the same. All right, now, all of this, the whole point of this, is now we can solve for missing measures in triangles using these ratios. All right, so what I'm going to do is divide by b on both sides and divide by a on both sides, and essentially, this is the law of sines. So this is really all you need to know. What we just did on the last slide was getting us there, like where that came from, but this is the law of sines. The sine of a over a equals the sine of b over b, where the little letters are the sides of the triangles that are across from those angles. So see how angle A is across from side A and angle B is across from side B? Okay, so this ratio is true because of all this stuff that we just looked at right here. So we can use this ratio to find missing measures of triangles that we wouldn't be able to find using other sines and cosines because we wouldn't have had enough information. So this ratio, sine A over A equals sine B over B, also continues. And you can say sine C over C as well. Okay? Remember that the big letter goes with the angles and the little letter goes with the opposite side. So that means, for example, if this were A, B, C, and this were X, Y, Z, A goes with which side? Y. B goes with Z, and C goes with X. How come? Those are the opposite ones. So if you draw from here to the opposite side, you're going across the triangle. Okay, so now we're going to use that to find all types of missing measures. All right, so we're basically setting up more proportions. This time we're using 2 sines and 2 angles. So take a look at how this would look. All right, so what information do I have right here in this triangle?
2 angles.
I have 2 angles and 1 side. If I have 2 angles, that means I also can have what? The third? How? Yeah, so 105 plus 32 would be 137. And then what would this angle be then? 53? 43? Okay, so that one's 43. So we have all 3 angles, and we're trying to figure out what? We're trying to figure out side DF. So I want to know DF, so I'm going to mark that X. All right, if I'm using the law of sines, I want to use 2 angles and 2 sides. One of my sides is going to be this one, because I know that one. And one of my sides is going to be this one, because I'm looking for that one. So I don't care, in this case, about which side. Which side don't I care about here? ED. I don't care about that one because it's not the one I know and it's not the one I'm looking for. All right? Now, what angle is across from 18? D, so that will be, all right, what angle is across from X? E, so that's, so then the sine, law of sines would be sine 105 over 18 equals sine 32 over X. Okay, because we have sine of 105 over the side that it's opposite, which is 18. And then sine 32 over X, because that's the one that's opposite. So did I need to use that 43? No. All right, the reason I did that is because sometimes you will need to use that third angle. Okay, now how would I solve this? Yeah, the same way we've been solving them. We're just going to cross multiply, so you end up with 18 times sine 32 equals sine 105. Yes, times X. So can somebody do 18 sine 32 and give me 2 decimal places? And then how would I finish it? Yep, divide by sine 105. And then that would give me
8.
good. So then this side would be 9. Nope. This side would be 9.88. So you're doing 9.53. So what I would ultimately do on your calculator is when you get 9.53, just hit divided sine 105 because it'll input that answer for you.
Wait, all we do
Yep.
is sine 105 divided by 19?
No, 9.53 divided by sine 105. So remember, if 9.53 is on the top, that's the one you have to put in first. Okay, what if I'm looking for an angle? What are you probably going to have to do if you're looking for an angle? Sine negative, right? So we're talking law of sines. This is always sines. So what do we have here? We have 2 sides and an angle. Which angle am I looking for? S. I'm looking for this one right here. Which one is that across from? 5. Okay, so what's my proportion going to look like here? Sine 75 over 7. Why? Because those are across from each other. Okay. Not just x. Sine x. Good. Sine x over 5. Good. Okay, how do I do this now? It's still a proportion, so I still have to start by doing what? Cross multiplying. So I'm going to start by doing sine 75 times 5 equals 7 times sine x. Okay, now, what's sine 75 times 5? 4.83 equals 7 times sine x. Now, what do I have to do next? I have to divide by 7. And it should be some kind of small decimal, right? Okay, now how do I finish? Because remember, I'm not looking for sine x, I'm looking for x. So how do I get rid of this sine x? Sine negative 1 of 0.69.
Is there a specific rule that not even?
Oh, you have it as a fraction? I think if you change it to classic. Yeah, change it to classic. All right, so then what does that give you? 6.3? Good. Okay, so just one step longer. You're doing exactly the same stuff. And then at the end, when you have sine x, to get rid of it, you do sine negative 1. All right? Whenever you're looking for an angle, you're always going to use that -1, that inverse. Okay? How did we set up the proportion? How did we know that we had to use 75/7 and sine x over 5? It's the opposite sides, and those are the ones that you had. Bianca? Yes, so this is the law of sines. This only works with sines because if you go back to the very beginning, what we looked at with the altitudes, that has to be the opposite in hypotenuse. We're going to talk about law of cosines next, but law of cosines is like just a longer formula to memorize. Always sine. In law of sines, in this proportion, yes. This proportion doesn't work for tangent or cosine. All right, it only works for sine. Okay, so take a look at the practice problems. Hang on, before you go up to start them, for 2 of these, actually, I'm just going to do them, tell you guys. For 1 and 3, be careful what you're looking for, AC and BC, because you're going to have to figure out, like, the other angles in those, okay? All right, so you're going to have to figure out what angle C is because that's the one that's opposite the side you know. So again, how would you figure that out? Add them up and subtract from 180. Good. All right, so just do either 1 or 3, one of these and one of these. So you're only doing 2, one of the odds and one of the evens. I don't care which one. Okay? All right, go ahead. All right, so the law of sines can work with any type of triangle as long as you have either 2 angles and a side, and it has to be the included side, or if you have 2 sides and an angle. Now, sometimes you're not going to have those, and so the law of sines won't work. So then you'd have to use the law of cosines. The law of cosines is a little, it's a lengthier equation. All right, so it looks a lot more complicated. It's not necessarily more complicated, it's just it looks longer. Okay, so the law of cosines says that if you know the side lengths or one of the angle lengths, so again, if you have side, 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 or 2 sides and an angle, you can use the law of cosines. So this is basically 3 different formulas, but they're all exactly the same. All right, do you guys recognize anything from these formulas? It looks like the Pythagorean theorem, right? So it's related to the Pythagorean theorem, and basically what you're doing is using the Pythagorean theorem and then subtracting this cosine ratio from that to give you missing sides. So the law of cosine says something like, if I have a squared, or if I'm looking for a squared, again, the little letter is the side and the big letter is the angle. Okay, so let's say I'm looking for a, then I would use b squared plus c squared minus 2 times bc cosine a. So again, it's a long equation, but you're just plugging in stuff. So it's not necessarily difficult, you just have to figure out what you're looking for and what you're missing. So for instance, if I'm looking for bc here, bc is right here. So that means it's across from which angle? A, so that means it's basically side A. What is 14? Side C, and 9? Side B. So if I'm looking for A, then I'm going to use that first variation. So the law of cosines would be a squared equals b squared plus c squared, so like the Pythagorean theorem, minus 2 times bc times cosine of A. So when you're going about trying to memorize the law of cosines, if it starts with A, it should end with A, and all the other letters should be the other 2, so BC. Okay? So if we're looking for A, this is the one we use. So this is going to stay a squared. That's the one here. Yep, you're either looking for this one or you might be looking for that angle. All right? Which one would be b squared? 9 squared plus 14 squared minus 2 times 9 times 14 times cosine, and what's A? 62. Perfect. You're literally just repeating them. So it looks like it's going to be really hard to memorize, but it's honestly just like this one should be the same as this one, and the others should be the same as the others. the same, yes, the last one is an angle because it's cosine of A.
So it's always going to be cosine?
Yes, because this is the law of cosines. So previously it was always sine because it's the law of sines, and that was a ratio. And the law of cosines is just this formula, and it's always going to be cosine. Okay? You just do this multiplication. You don't really yes, you can think of it like distributing, but you don't really have to because it's just 3 multiplication problems. So what's 9 squared? What's 14 squared? What's 2 times 9 times 14? 2 what? 52? Okay, what would we do next?
And then will we add up 81 and 96 and then subtract?
You would add these, but you can't subtract this until you do what? You got to do the multiplication. So you got to do 252 times cosine 62 first. Because PEMDAS. Order of operations tells you have to do multiplication before you can do addition and subtraction. So addition of 81 plus 196, and then what's 252 minus cosine 62? Sorry, times cosine 62.
I got 118.
118.3? Okay, and then what's 81 plus 196? What? Okay, and then 277 minus 118.3? How would I finish this? If I have a squared, what do I need to do to finish?
Square root of
Good, square root of 158. So you can either just leave that as 158.7 with the square root, or you can find it. And it should be... What? I'm not trying to kill you. Is it working? Oh, that was weird. 12 point what? 60. Okay, sorry. Okay, so that's a lot of actual writing, but the work itself is just on your calculator. Honestly, you don't even need to do it step by step as long as you use parentheses. You can put the whole thing in your calculator as one step as long as you put this part in parentheses. Okay? Would I do that? I don't know. People make a lot of mistakes because they always forget parentheses, so I would probably do maybe this part and then this part separately. But the biggest thing that people forget is they try to do 81 plus 196 minus 252, which is fine. You're not alone. Everybody does that. But just remember, order of operations, you have to do multiplication first. So again, this looks like a lot of stuff. It looks like a lot to memorize. But if you just remember that whatever it starts with, it has to end with, and the other stuff is the same, there's not that much to remember. I'll give you guys this formula for the test. Okay? I don't really care if you can memorize formulas. I'd rather you be able to apply them. All right, so how would I do this all if I wanted to find an angle? You're doing the same thing, but at some point you're going to have to do what? To find an angle. Cosine -1 at some point. So I'm looking for angle R, which means that what do I want to start with? R squared equals S squared plus T squared minus 2 times ST cosine R. Okay, so again, R, and then these are both STs. Okay, so plug it in for me. What's R squared? What's S squared? 7 squared. What's T squared? Okay, what's 9 squared? What's 7 squared? What's 4 squared? What is 2 times 4? 2 times 4. 8. 8 times 7.
Wait, what did you say? 2 times what?
I said 2 times 4, which is 8, only because when I do 2 times 7, I get 14. I don't know 14 times 4 off the top of my head, but I do know 8 times 7 quickly. So it's commutative. You can mix up the order. All right, now, what are we going to do here? I would write this down because this is where I think, if I had to guess, 90% of people make mistakes on this part.
49 plus 16.
Okay, so you've got to do 49 plus 16, which is 65. Okay, are we going to do 65 minus 56 or subtract 65 from both sides? 65 from both sides, because you cannot do this since this is held together with what? Yeah, so you've got to do minus 65, bless you. And you end up with negative 56 times cosine r. How do I get rid of the negative 56?
Wait, on the calculator, how can you do like minus 81 equals, you just don't put the 81? Whenever you're going to do the whole thing on the calculator.
So you can't do this whole thing on the calculator because you're looking for this angle.
So, but like if we did this one, I could put the whole thing on the calculator.
The one before it, yes, because you have all the letters to the right.
But so how would you do it? So you put the number.
The 2, after the 2, put that in parentheses.
Oh.
Okay? All right, so then 16 divided by negative 56 gives you what?
Negative 029.
Okay, and then how would I finish this if I'm looking for angle R? Cosine negative 1 of negative 0.29. So, is there a lot there? Yes, there is a lot there, which is one, why I'll give you the formulas, and two, why I'm not going to ask you to do like 20 of them. Okay? There's a lot to do here, so there's a lot of steps, but again, it's basic algebra. So if you're remembering your algebra right, then you should be fine. The biggest thing to remember is how do you get rid of a cosine? Cosine negative 1. So the opposite of cosine is inverse negative 1.
But like this one, the text that we're a little bit off on.
If you're a little bit off because you rounded at a different point, that's fine. Because I never round. I always just hit second and get like the little answer. So I don't ever round until the very end. But if you round first, like I'll look at a range. Probably for here, what did you get? Yeah, like you got 106.85. I would probably take anywhere from like 105 to 107. Because as long as you're within that range, you did it right. You just rounded at a different point than me. So I don't care when you round. Okay, go do one of these on the board. Any one you want to do.
Are they different? Like,
They're not like the last one where, like, they should all be relatively the same.